Hi everyone, this will be a video for applications of differentiation, most specifically your first derivative test. So we might ask ourselves, what's the purpose of the first derivative test? And you can see on the screen here that we pretty much use it to determine characteristics of a graph. Our goal is to be able to graph a function f of x, and we can figure out extrema, we can figure out intervals of increasing or decreasing behavior. We'll also be able to find something else out with our second derivative, so that'll be coming up soon. So this again is going to be guiding us to graphing. Keep that in mind, that is our goal, to get characteristics to graph. So we do need to know what we can find from our first derivative test. We have two things here. The first thing we're going to talk about is extrema, and then the second thing would be our intervals. So when we're talking about extrema, that's your maximum or minimums. You can only have extrema at something called a critical number, okay? That's the only place that an extrema will occur. And you can find your critical numbers, this is an important step here, by setting your derivative equal to 0. Okay, so when we said that they only occur at critical numbers, they also only occur when the sign of f prime, of the derivative, is changing from positive to negative or negative to positive. And really what's going to be happening there is you're going to be able to see that your graph is going to be decreasing, and then it's going to get to a point where it's going to start increasing, and you'll have a minimum at that point, or the opposite with a maximum. So that's why we have to find step 2, which is our intervals, right? Our intervals where it's decreasing or increasing. And we can find that by finding our critical numbers. We're going to set up a table, and you're going to see that on the next page. Once we set up a table, we'll be able to choose a test value. Whatever value we choose in an interval will represent any value in that interval. So it's going to help us be able to determine if the sign comes out greater than 0, which means positive, then it's increasing. And in the other turn, if the sign of your derivative is less than 0, which means it's negative, then it's decreasing. So here are the steps for using the first derivative test. And I do suggest writing these down, having them on a note card or a piece of paper. So first we're going to find our derivative. Then we're going to set it equal to 0 and solve for x. Whatever values we get here, and you might get multiple, they'll be your critical numbers for the problem. We're going to set up a table using these critical numbers. We're going to choose test values in those intervals. We're going to plug those values in and actually determine conclusions, and then also determine extrema. So you're going to see all of these steps within our next problem. So here we go. In green you can see that our problem is asking us to find all extrema and intervals of increasing or decreasing behavior of this function f of x. So f of x equals negative x to the fourth minus 8x cubed. So the first thing we need to do is find f prime. So I'm just going to write my original here again, just so it's a little bit bigger. All right, and so then this one's pretty straightforward. We're just going to have to use our power rule. So we're going to bring our exponent down to the front, subtract 1. Multiply our exponent down to the front, so we get negative 24 x squared. Okay, and now we can move down to step 2. And step 2 is going to be when we take this derivative. So I'm just going to write it here again. And we're going to set this equal to 0 and solve. So we set equal to 0. I'm going to notice what I can factor out. I can factor out a 4 and an x squared. So that means I'm going to be left with x plus 6. So we can set each factor equal to 0. So we have negative 4x squared to equal 0 and x plus 6 to equal 0. And when we do, you can see that we're going to have x equals 0 and x equal negative 6. These are our critical numbers. All right, so we have x equals 0 and x equals negative 6. So we're going to use these critical numbers, and we're going to create intervals. So this is what your table is going to look like. You're going to have 4 rows. It's going to start with intervals. That's our first row. We're going to have a test value, and those are going to be values in that interval, not the endpoints. We're going to have our sign of f prime of x. It's important you don't shorten this. You want to make sure you notate that you're plugging it into the derivative. And then we're going to have our conclusion. So when I'm looking at this, when I'm looking at my critical numbers, we can write our intervals starting at negative infinity to our smallest critical number, well, for us that's negative 6. And then we have to link our values, so negative 6 to 0. We should be covering every value on the number line. So from negative infinity all the way to positive infinity. Notice as there's no jumps or gaps. So now we're going to move down to our step 4. Notice I just already have my table ready for me. And we're going to be choosing some test values here. So you want to choose values that are within the interval, choose easy values, and values that are not on the endpoint. So for instance, we could choose negative 7, negative 1, and 1, and they would all be pretty great test values. All right, so once we have all of these values chosen, all of our test values picked, what we're going to do is we're going to take these values and plug them into our f prime. So you're going to find f prime of negative 7. You plug it in, and you're going to get a value. So for instance, this value is 196. I don't really care about the value. You care about the sign. So you care that it's positive. Same thing over here. You're going to take your derivative. You're going to plug in negative 1. You evaluate, and you're going to get a negative 20. So this one, you don't care about the number again. You just care about the sign. It was negative. And then our last one, we're going to find f prime of 1. When you plug that one in, you also get a negative 28. And that means that you have another negative. Sometimes these will alternate. Most often they do. But this does occur where you have like a plus, minus, minus, or if you had like a plus, plus, minus. But usually you do see some alternation here. All right, so now that step 4 is done, let's go down to step 5. When we're looking at step 5, we need to talk about our conclusion line, whether or not it's increasing or decreasing. And as we stated on our last slide or slide before, if our derivative has a positive value, so right here how it has a positive value, that means that it's increasing. So we're going to use just like a really simple upward slanting line to show that it's going upwards. On the other hand, if it's a minus, that means that it's decreasing. And again, we have another section that it's decreasing. And again, that's normal. When you're writing out your solution or if you're typing it in, it might ask you for the intervals of increasing or decreasing behavior. So you would be able to say increasing, and then we'll list the intervals here. So it's going to be increasing during negative infinity to negative 6, and then it'll be decreasing through my other intervals, so that negative 6 to 0, and then also 0 to infinity. So now that I'm looking at it, you could probably just do negative 6 to infinity. Let's go down to step 6. All right, so this is the very final step that will determine some information. Now you can notice that this line is pretty much like the time that x equals negative 6, and this line over here is pretty much like when x equals 0. So we're trying to determine extrema, and what you can remember is that extrema only occur when we're switching signs. So you can see here we're increasing during this whole interval. Then we're going to get to this point when x equals negative 6, and then you can see we start decreasing. And that's really why this conclusion line is helpful, because you can visualize we're going up, we get to this line, we switch, now we're starting to decrease. So this visual is telling me that it's going to be going up, and then it's going to decrease right here. So that's telling me I'm going to have a maximum at x equals negative 6. So we do need to find this whole point, and you're going to plug that into your original function. So remember, we're trying to graph this original function, and when we do, we'll have this point from the original function's graph. So plug it into your original one. So we have f of negative 6, so it's going to be negative 6 to the 4th minus 8 times negative 6 cubed. So that was our original function here. We plug in negative 6. When we do negative 6 to the 4th, let me just grab my calculator, so negative 6 to the 4th. Okay, so we have our negative, and then when I do negative 6 to the 4th, I get a positive 1296. And then I have a minus sign here. I'm going to do my negative 6 to the 3rd. I'm going to get 8 times negative 216. And using a little bit of math here, you're going to get the value of 432. So this is the full coordinate point here. It's going to be negative 6, 432. Clearly, this is not a point you're going to be graphing. but you use the same method to find those points.